NASA has announced that water could be spewing from the surface of one of Jupiter's moons.
I couldn't believe what I was hearing, but the source was undeniable.
Is a crater at the south pole of the moon called Shackleton.
A former NASA astronaut has finally decided to break the silence, and what he revealed about the moon is nothing short of astonishing. We've all heard the theories and the speculation, but this is something else entirely. Strange structures, unexplained activity, and secrets buried for decades. His confession has left experts reeling. So, let's get into it. Well, if you thought finding water on Earth was no biggie, hold on to your hats, because in 2020, scientists found water on the moon's sunlit surface. Not in the shadowy, secretive nooks and crannies, but right out there in the bright lunar daylight. This discovery was made by the Stratospheric Observatory for Infrared Astronomy, affectionately called SOFIA. Now, SOFIA isn't your average bird. It's a jumbo jet with a mighty telescope that flies high above the Earth's clutter, peering into space without the usual atmospheric distractions. On a fine day, October 26, 2020 to be precise, NASA dropped the news that SOFIA had spotted water molecules in Clavius Crater, a giant on the moon's southern hemisphere, and quite the sight from Earth. The water detected wasn't like finding a lake on a hot day, though. We're talking about a scant 100 to 400 parts per million. Picture a tiny water bottle's worth spread over a football field of lunar dirt. In fact, the driest place on Earth, the Sahara, would seem like a water park compared to its 100 times more water than our dusty moon's new find. Before this, signs of hydration were teased on lunar grounds, but scientists were in a pickle over whether it was actual water, H2O, or just its close cousin, hydroxyl, OH, thanks to SOFIA's eagle eye, capable of catching water's unique 6.1 microns wavelength. It was an open and shut case. Definitely H2O. Now, why doesn't this water just bounce off into space, given the moon's lack of VIP atmosphere? Well, researchers have a hunch. They think it might be playing hide-and-seek in tiny glass beads, courtesy of micrometeorites, or tucked away between soil grains, safe from the harsh lunar playfield. This isn't just cool moon trivia, it's vital intel. Knowing there's water handy could mean astronauts sipping on lunar lattes, breathing easier with oxygen pulled right from the moonshine, and even rocket fuel on tap for deeper space jaunts. This could change the whole living on the moon game, making longer, more ambitious missions possible. Speaking of groundbreaking lunar tales, let's jet over from water to fire. In June 2024, the Chang'e 6 mission, courtesy of China's ambitious space program, made headlines by bringing back the first ever samples from the mysterious far side of the moon. That's right, not the side we're used to staring at every night, but the one that's been playing hard to get, hiding all its stories. This isn't just any moon dust we're talking about. Landing in the gigantic South Pole Aitken Basin, a big and old crater that makes the Grand Canyon look like a scratch, the Chang'e 6 mission scooped up about 4.25 pounds of lunar soil and rocks. And oh boy, did those rocks have tales to tell. Analysis of these samples turned up basalt fragments dating back to between 4.2 billion and 2.8 billion years ago. This means volcanic activity was hanging around on the moon's far side for over 1 billion years. Who knew the moon had such a fiery past? Up until now, our whole playbook on lunar volcanism came from the near side, thanks to the Apollo missions and some of China's earlier space adventures. Those samples hinted at volcanic activity dating from about 3 to 4 billion years ago. But thanks to Chang'e 6, we now know the far side wasn't just sitting pretty. It was bubbling with volcanic activity for a much longer time. This revelation throws a wrench in the old assumptions about the moon's geological history. It seems the moon kept its interior cooking much longer than we thought, challenging what we know about its thermal evolution and how different its two sides really are. The jackpot of data from Chang'e 6 isn't just a win for China. It's a global high five moment. with scientists from around the world diving into this treasure trove of information, the mission underscores the cool stuff that happens when countries collaborate in space exploration. It's not just about planting flags, but also about piecing together the cosmic puzzle of our very own moon's epic backstory. And while we're on the topic of groundbreaking, let's not forget the astronauts of Apollo 17, who, back in December 1972, were doing their own moon dance in the Taurus-Littrow Valley. Their historic mission brought back a different kind of moon magic. Their mission? To scoop up geological samples and crack open the mysteries of the moon's dusty past. And boy, did they deliver. While prancing around near Shorty Crater on December 12, 1972, Schmidt, who wasn't just an astronaut but a trained geologist, stumbled upon something that would make any space nerd's heart skip a beat. There it was, right at the crater's rim. Orange soil. Yes, orange, in a sea of endless gray. This was no small deal. Imagine the scene back at Mission Control, the buzz of excitement as Schmidt's voice crackled through, declaring his colorful find. This wasn't just any orange dirt, but a treasure trove of tiny, spherical glass beads bursting with titanium and shy on silica. These little orbs dated back a cool 3.6 billion years, a relic of a time when volcanic fireworks, think lava fountains erupting into the lunar skyline, were all the rage. Once they shot up and cooled off, they settled back down as these fetching orange beads. Back on Earth, this discovery was a game changer, shedding light on the moon's explosive personality and hinting at a history more dynamic than previously imagined. Fast forward to the sample's earthly debut, and there they are, the stars of the show at museums like the National Air and Space Museum. This splash of color from our celestial neighbor not only spices up the gray palette we're used to, but also underscores the sheer coolness of having scientist astronauts getting their hands dirty in the lunar regolith. It's these moments of unexpected discovery that remind us why we shoot for the stars, or, in this case, the moon. Now, from the surprising to the downright chilling, let's talk about some of the moon's most secretive spots. Back in October 2009, the boffins at NASA were onto something pretty cool with their LCR-OSS mission. You see, they were not just poking around the moon for the fun of it. No, sir. They were on a hunt for water ice, hidden away in the moon's coldest, darkest craters, especially near its elusive South Pole. And guess what? Bingo! They hit the jackpot, launched side by side with the Lunar Reconnaissance Orbiter, LRO, on June 18th, 2009. L-Cross's main gig was to sniff out the presence of water ice in those perpetually shadowy spots on the moon that never see the sunlight. These areas are chilly beyond imagination, staying colder than a winter night in Siberia. Just the kind of places you'd expect to stash some ice for millennia. So, on the morning of October 9th, 2009, at precisely 11:31 UTC, NASA's team did something that was half science, half Hollywood stunt. They crashed the Centaur upper stage of a rocket right into the Cabeus crater. And not just for a spectacular show. This dramatic impact kicked up a whole bunch of lunar dust and debris, creating a plume that the following L-Cross spacecraft could fly through and analyze. Now, 4 minutes after the crash, as the debris was still dancing in the lunar low gravity, the L-Cross spacecraft zipped through this cloud of mystery, scooping up data. Lo and behold, it finds not just rock and dust, but actual water vapor and ice particles. That's right. The stuff of life, swirling around in the lunar shadows. The implications are as cool as the craters themselves. Some of these shadowed pits are colder than Pluto, hovering around 35 Kelvin. That's minus 238 degrees Celsius. Or, if you prefer, a frosty minus 397 degrees Fahrenheit. Water ice hanging out there could be a game changer for future moonwalkers. It means potential drinking water, yes, but also oxygen and even rocket fuel. This stroke of genius by NASA, using a spent rocket stage as a battering ram, not only saved a pretty penny, but also opened up new chapters for lunar exploration. Think about it. Water on the moon could mean longer stays, maybe even a pit stop for deeper space adventures. And speaking of turning the impossible into the possible, How about that time scientists aboard the International Space Station whipped up a Bose-Einstein condensate in June 2020? Known as the fifth state of matter, this isn't your everyday science experiment. This all went down in NASA's Cold Atom Laboratory, which, despite its icy name, is actually a hotbed for ultra-cold quantum gases experiments in the zero-gravity playground of space. So, what's a Bose-Einstein condensate? It's a state of matter that occurs when a group of bosons, those are particles that follow Bose-Einstein statistics, get cooled to temperatures near absolute zero, which is a brisk minus 273.15 degrees Celsius, or 0 Kelvin if you prefer. At this frosty temperature, the particles don't just shiver, they snuggle up into the same quantum state, acting as a single quantum entity. This party trick was first predicted by none other than Albert Einstein and Satyendra Nath Bose back in the early 20th century, but no one actually saw it happen until 1995. The Cold Atom Laboratory, a creation of NASA's Jet Propulsion Laboratory, JPL, was sent up to the ISS in May 2018. Its main gig is to poke around the properties of these ultra-cold quantum gases without the downer of Earth's gravity. This microgravity stage lets scientists observe the particles for longer and with fewer disturbances than on Earth, allowing them to explore quantum phenomena that would be too shy to reveal themselves under Earth's gravity. Thanks to the low-gravity environment aboard the ISS, Cal was able to cool rubidium atoms to just a hair above absolute zero, successfully forming a Bose-Einstein condensate. The kicker? The lack of gravity let these condensates hang around for over a second. That's way longer than on Earth, where gravity plays party pooper and disrupts the observation party early. Robert Thompson, the CAL project scientist at JPL, was quite thrilled, explaining, "The laws of physics are universal, but how they show up can really change depending on where you are. Seeing Becks behave in space helps us investigate the basic behaviors of matter under conditions that are truly out of this world." This cosmic breakthrough not only opens thrilling new doors for quantum mechanics research, but could also pave the way for rad advancements in technology. Think super-sensitive quantum sensors and next-gen atomic clocks. Plus, diving into how matter behaves under these extreme conditions could offer some serious clues about the deep laws that rule our universe. But wait, there's more. While scientists were busy bending the rules of physics, nature was crafting its own spectacle in the outer reaches of our solar system. Back in the early 1980s, NASA's Voyager missions gave us a front-row seat to something you've got to see to believe: a hexagon-shaped storm swirling on Saturn. Both Voyager 1 and Voyager 2 managed to snag some shots of this cosmic oddity during their flybys in 1980 and 1981. They saw a geometrical marvel that seemed more at home in a math textbook than swirling around the North Pole of a gas giant. This hexagon, parked firmly at about 78 degrees north latitude, stretched over 14,500 kilometers on each side, making it wider than Earth itself. Now, if that doesn't put things into perspective, this mammoth structure spins every 10 hours, 39 minutes, and 24 seconds. Perfectly in sync with Saturn's internal radio emissions. Talk about a cosmic dance move. It hints at a deep connection to the planet's rotation, something that kept scientists scratching their heads for a good while. In 1988, a brainy astronomer named David A. Godfrey took a deep dive into the Voyager data and formally introduced the world to the hexagon, turning it into an atmospheric celebrity of sorts. After the Voyagers said their goodbyes, Saturn's North Pole took a little nap in the darkness, thanks to the planet's axial tilt. This left the hexagon playing hard to get, eluding the eyes of astronomers until a new player entered the scene. Enter NASA's Cassini spacecraft, which arrived in 2004 with its bag of high-tech tricks, ready to shed some light on the situation, literally. But even Cassini had to wait until 2009, when Saturn's North Pole finally stepped back into the spotlight. Once the lights were back on, Cassini went to town. It sent back high-res images and videos showing the hexagon in all its glory, along with a massive hurricane at the center, sporting an eye about 50 times larger than what we see in hurricanes on Earth. And just for good measure, it threw in some smaller vortices, these little reddish ovals dancing around, some clockwise, some not, adding to the cosmic ballet. As mesmerizing as Saturn's hexagonal storm is, it's not the only star, pun intended, of the outer solar system's show. Take the faint star discovered in 1999 by astronomer John Gizis and his team during the 2-micron All-Sky Survey 2 MASS. This star, tagged as 2 MASSJ 23062928-0502285, because, let's face it, astronomers love coordinates, didn't cause much of a stir initially. It was just another ultra-cool dwarf star chilling in the infinite expanse. Fast forward to 2015, and things start getting spicy. Enter Michael Guillon and his team from the University of Liège in Belgium, armed with their trusty TRAPPIST telescope at Chile's La Silla Observatory. Their mission? To scope out planets around stars that won't burn your eyebrows off. From September to December that year, they kept their eyes peeled on our previously uncelebrated star and noticed some intriguing dips in its brightness. These weren't just your average twinkles, but potential cosmic blockbusters. By May 2016, the plot thickened as they hit the jackpot. 3 planets were caught red-handed as they danced across their star, and in a nod to their telescope, they named their stellar stage TRAPPIST-1. But why stop at 3? The team had a hunch there was more to this story. So they teamed up with NASA's Spitzer Space Telescope, which peered through cosmic dust clouds in infrared to keep the stakeout going. Their hunch paid off big time. After nearly 3 weeks of continuous observation, Spitzer delivered a twist better than any season finale. TRAPPIST-1 didn't host 3, but 7 Earth-sized planets. Cue the collective jaw drop in the astronomical community on February 22nd, 2017. These new cosmic characters, dubbed TRAPPIST-1b through H, brought the house down, especially since 3 of them, E, F, and G, were hanging out in the habitable zone. That's the celestial sweet spot where planets could potentially host coffee shops, and maybe even life. TRAPPIST-1, a humble red dwarf with just 9% of our sun's mass and only a tad larger than Jupiter, was quite the planetary party host. These planets are so close to their star that the most distant one, TRAPPIST-1H, wraps up its orbit in about 19 days. Even Mercury takes 88 days to orbit our sun. This stellar revelation was a game changer, finding a whole family of Earth-sized planets, some potentially able to host life, hanging out around one star. It suggests that the universe might be packed with similar systems, boosting our odds of bumping into extraterrestrial neighbors. And with the James Webb Space Telescope on the horizon, we're future planning, aiming to dive into these planets' atmospheres and maybe RSVP to the cosmic party. As we marvel at these celestial wonders, let's not forget about the surprises lurking closer to home. Jupiter's moon Europa, observed by the Hubble Space Telescope in December 2012, revealed what looked like water vapor shooting up from Europa's surface near its chilly south pole. And these weren't just little geysers. They soared up to 200 kilometers high. That's over 20 times the height of Mount Everest. This was a big deal because a massive ocean was just waiting to be studied beneath Europa's icy exterior. If these plumes are really sprouting from that ocean, they could give scientists a sneak peek into its secrets without the hassle of drilling through miles of ice. Fast forward to May 2018, and things got even more interesting. Scientists were sifting through old data from NASA's Galileo spacecraft, which had zoomed past Europa back in 1997. And guess what? It likely flew right through one of these elusive water plumes. This little bit of serendipity provided a much-needed double confirmation that Europa is actively spewing water into space. Catching these plumes in action is tough. They're not exactly the reliable type, popping up sporadically and sometimes playing hard to get. Hence, the big brains continue to keep an eye on Europa, with telescopes like Hubble leading the charge in celestial surveillance. In an exciting twist, NASA didn't just stop at watching. On October 14th, 2024, they launched the Europa Clipper mission. This specially designed spacecraft is all set to dive deep into Europa's mysteries, sniffing around for more plumes and studying the icy shell and ocean lying beneath. Set to swing into Jupiter's orbit by April 2030, the Europa Clipper is on a mission to make multiple close flybys of Europa. Each pass could potentially fill in the blanks about this mysterious moon's aquatic allure. But let's not forget about our own backyard in the cosmos. While Hubble was eyeing Europa, NASA's Curiosity rover made its own headlines in Gale Crater on Mars. Landing there in August 2012, Curiosity kicked off a Martian saga that's been nothing short of a geological blockbuster. You see, Gale Crater is this massive bowl on Mars, about 154 kilometers, 96 miles across, with a mountain right smack in the middle. It's like the Grand Canyon of Mars, if you will, and scientists had a hunch it was once filled with water. Talk about beachfront property billions of years ago. So what was Curiosity up to in this Martian oasis? Well, it was busy sniffing and drilling rocks like a robotic bloodhound. And oh, the treasures it found. In December 2014, Curiosity hit pay dirt, or should we say pay rock. The rover's lab, known as the Sample Analysis at Mars, SAM, detected organic compounds in the powdered samples it collected. This wasn't just any old Martian dirt. These were organic molecules nestled in the sedimentary rocks at Gale Crater, hinting that this part of Mars might have been habitable once upon a time. This discovery was like finding the secret ingredient to the primordial soup that could have supported life. It painted a picture of ancient Mars, buzzing with activity, having liquid water, and a climate more akin to a walk in the park than a scene from a frozen tundra. And while we're not saying there were Martians paddling around, these findings are crucial breadcrumbs leading scientists on the hunt for past life. But as we marvel at the past, let's not forget we're racing toward an expansive future. Speaking of expansion, let's talk about something a little closer to home, but no less mind-boggling: dark energy. In 1988, Saul Perlmutter from the Lawrence Berkeley National Lab started rounding up a global gang of astronomers for the Supernova Cosmology Project. Their mission? To measure how fast the universe was expanding by keeping an eye on Type 1a supernovae. These space fireworks are perfect for this kind of job because they always shine with the same brightness, making them cosmic measuring tapes. Now, flip the calendar to 1994, when Brian P. Schmidt of the Australian National University and Nicholas B. Suntzeff from the Cerro Tololo Inter-American Observatory in Chile kicked off the High Z supernova search team. Their game plan was pretty much the same: track down those distant supernovae to chart the universe's growth. Both crews were betting on finding a universe that was taking it easy, gradually slowing its roll under the cosmic pull of gravity. But nope, the universe had other plans. By 1998, both teams had their minds blown. Those far-off supernovae? It was dimmer than expected. This dimness hinted that they were further away than their redshifts would suggest, leading to one jaw-dropping conclusion: the universe's expansion was hitting the gas, not the brakes. This twist in the cosmic tale snagged the title of Breakthrough of the Year from Science magazine in 1998. And just when you thought it couldn't get any cooler, the 2011 Nobel Prize in Physics went to Saul Perlmutter, Brian P. Schmidt, and Adam G. Rees for leading this interstellar detective work. Thanks to them, about 68% of the universe's dark energy isn't merely theory, it's the new frontier in astronomy. Who says looking up at the stars is just daydreaming? These astronomers turned a gaze at the heavens into a revolutionary chapter in science, once again proving that the universe has more surprises up its sleeve than we can imagine. Now let's leap from the far reaches of outer space to our own cosmic backyard. The same sense of wonder drives NASA's Juno mission, which has been busy unraveling the secrets of Jupiter's atmosphere. Launched back on August 5th, 2011, Juno was like the ultimate cosmic road trip, taking 5 years just to get to Jupiter, which it finally did on July 5th, 2016. The spacecraft had a laundry list of things to check out, Everything from what Jupiter's made of to its gravity fields, magnetic fields, and those wildly energetic polar magnetospheres. Diving right into the thick of it, Juno's been playing detective with Jupiter's zonal winds. These aren't your garden variety breezes, but massive wind patterns that burrow deep into the planet, extending around 3,000 kilometers, about 1,864 miles, below the cloud tops. And they're not just blowing willy-nilly. They line up in a cylindrical pattern along Jupiter's rotation axis. Pretty neat, right? Then there's the view from the top, or should I say tops, since Juno has given us a front row seat to the cyclone action at both of Jupiter's poles. At the North Pole, you've got 8 massive cyclones, each nearly 4,000 kilometers, 2,485 miles across. Head south, and you'll find another 5, some stretching over 6,000 kilometers, 3,728 miles in diameter. And these storms are stable, persisting with winds that rip through at speeds between 150 and 350 kilometers per hour, 93 to 217 miles per hour. And oh, the great red spot? That iconic swirling tempest isn't just a surface feature. It plunges down about 300 kilometers, 186 miles, below the cloud tops. Juno's sneak peeks suggest it's warmer at the base than up top. Plus, the storm doesn't seem to go deeper than 500 kilometers, 311 miles. Insights like these are gold for figuring out what makes this giant storm tick. Topping off Juno's highlight reel is the lowdown on Jupiter's atmospheric makeup. Turns out ammonia isn't just hanging out evenly mixed up there. Near the equator, it's abundant and pretty consistent, depth-wise. Elsewhere, not so much, likely thanks to these wild mushballs of ammonia-rich hail forming during storms, hauling ammonia down into the deeper layers. And let's not forget about Jupiter's own brand of lightning. Some of it forms way up high, in the super chilly upper atmosphere, far from where you'd expect any liquid water to be hanging around. Now, isn't that a twist? While we're all down here dealing with our own weather whims, Jupiter is redefining atmospheric science's wild side. Now, shifting gears without really shifting, let's glide over to Saturn's moon Enceladus. Discovered by NASA's Cassini spacecraft in 2005, it revealed that Enceladus wasn't just another icy celestial body, but a dynamic world spewing secrets from its south pole. Developed by NASA with a little help from its friends at the European and Italian space agencies, Cassini launched in 1997, settling into Saturn's orbit by 2004, with a keen eye on the gas giant and its moons. Fast forward to March 9, 2006, when NASA dropped a bombshell. Cassini had caught Enceladus in the act, venting water-rich plumes like it was hosting its own galactic hot spring. These weren't just any plumes, though. They packed water vapor, molecular hydrogen, and even solid goodies like sodium chloride crystals and ice particles, with around 200 kilograms, 440 pounds, of material gushing every second. Some of it settled back on the moon like a light snowfall, while the rest went off to jazz up Saturn's E-ring. Now, if this plume cocktail reminds you of a comet, you're not alone. Cassini thought the same. This was the first hint that beneath Enceladus's frosty exterior might be a spa-like ocean, cozy and warm, possibly hosting tiny microbial life forms kicking back in the heat. It wasn't just the plumes that got Cassini all excited. It was also those tiger stripes, spotted for the first time in May 2005. These weren't just scratches on the moon's surface, but were warm, welcoming ridges that pointed to cryovolcanism still happening right now. By 2014, NASA was convinced that Enceladus had a massive, watery heart, around 10 kilometers, 6 miles thick, right under those tiger stripes. It's like Enceladus was practically inviting aliens to come and chill in its subterranean ocean spa. But all good things must come to an end. In a grand finale on September 15, 2017, Cassini took one for the cosmic team and plunged into Saturn's atmosphere. A fiery end to avoid messing up Enceladus or any other moons that might be scribbling "Welcome Earthlings" in their alien diaries. And just like that, Cassini's epic saga of discovery and protection wrapped up, leaving us all a bit wiser about our mysterious solar neighborhood. What do you think about these shocking revelations? Share your thoughts in the comments below. If you found this intriguing, don't forget to give this video a thumbs up, subscribe for more eye-opening space content, and hit the bell icon so you never miss an update.